everyone. I'm Navid Rekabsaz. I'm from as an assistant professor at Johannes Kepler University Linz in Austria. And I'm also an LP advisor in this fantastic project, DEEP. Really proud of that. And I hope we also have some connections to some of you and bring up some interest in you to also come and join us in this interesting and amazing project. Okay, so I think the last sentences that we had here was really a good connection to this specific session. So the question is that how we can now join or connect the human brain and what technology can bring to table. So a little like an overview of what's happening today. So this session hopefully would be 1 hour, probably a little go to the break time. We'll go deep into the technical part of the humanitarian sector for people who are interested to know what's actually happening, what's the state of the art, what are the forces happening in the technical part of the data analysis in humanitarian section. After then, we have topics of the ethics, and in the afternoon, we have a set of workshops and hands-on on the technical parts, also the demo of the system. So we have basically 2 parts about the technical parts. One is here, which is basically just a lot of presentation, discussions, Q&A, talking together, etc. And I would really invite you also in the afternoon where we have hands-on. We just do programming basically all together. And I would really love that you also join us there. Bring your laptop and let's have like a face-to-face discussion about the code, the process, the machine learning, this deep learning, PyTorch, et cetera, that's happening. So for this session, I think it would be good if we start with, start with Abdine. Yeah, that would be better. So we have 3 presentations now. Hopefully we have 3. Definitely we have 2. So the first one is, so we try to have a diverse set of what's happening generally in the humanitarian domain from technical point of view. The presentation of Nico, would be the last presentation, would be exactly about the DEEP project. What we have done so far and what we are envisioning and thinking about that we will be doing in future, and we really want to also think with us at how we can solve these problems. Besides that, we have 2 other interesting presentations that cover other aspects of humanitarian data analysis. The first is our fantastic Abdine here. Abdine, could you come and join us? Abdine has written as nice to say. So Abdine is an associate researcher in University of Ottawa. He's a data scientist researcher in the project COVID-19 Global South AI and Data Innovation Program in Senegal and Mali. So Abdine will have our first presentation, which has the title, Uses of NLP in the Fight Against COVID-19 in Mali and Senegal. So we kind of a little look how NLP can be applied to the area of COVID-19 in a specific region. After then, maybe if you want to, after then we have another presentation from Ted. He's in Boston from MIT. I really hope that he can join. It's almost 4 o'clock back then, so I hope that he wakes up. But that would be our second presentation, and the last presentation would be the Nico about the DEEP project. So, Abdine, would you like to start?
Yes. So, hi everyone, my name is Abdine.
Great.
I've already been introduced, so can I introduce a little bit my project? So the project is like to study the social impacts of artificial intelligence technology and even COVID restriction in a broad manner in Mali and Senegal. So in this project, I was working with the IDRC, University of Ottawa, University of Dakar, and it's founded by the Switch International Development. Okay, so first, let's start with the context of COVID and Mali and Senegal. Mali and Senegal are countries in West Africa. So there, the COVID pandemic hit really differently from other parts of the world. So one thing that we acknowledge is the small number of cases compared to other parts of the world. But there it was, even now I think it's like just a few thousand cases. So it's not that much. So maybe there is an obvious reason. Maybe those countries are poorer, so they tend to test less. But also there is a different reason. So the age repartition, so in those countries the population is really young, so maybe that's an explanation. And also the repartition. So most of them, so you have old people surrounded by young people, so it's like kind of protection for them, because COVID tends to kill more older people. And also the climate, people tend to live more outside, and COVID has a way of transmission, that's the aerosol, so that's also a thing. The strong political response, so when it started, the government just like the lockdowns came really rapidly, and also they have like previous experiences with other pandemics. So in West Africa, we had Ebola, so people already have the reflex to fight a global pandemic. So can take here the special case of Mali. In Mali, there is also another humanitarian context. There is like a security and political crisis. We have a lot of jihadism attack and all over the country. So in this context, the application of AI and data science to fight COVID can be really interesting, as it can help people like to locate where they have to act in priority, even if they have to do like small lockdowns. So it can be like a really useful things in those countries. However, it raises a lot of questions, because most of the time, tools are just taken from other part of the world and just applied there. So there is like adaptability and acceptability questions. So what's the project? So my project came into two parts. There were two main parts. So the first one was epidemiological modeling and socio-anthropological context in Mali and Senegal. So in this part, I work with Leonardo for UNHCR. So the model was to make a custom model to do prediction on COVID in developing countries. So with my team, we adapted the model specifically for Mali and Senegal. And also we are doing like a field survey in order to get like, because for this model, the sources are global data, and we try to use like more specific data. So we did like field survey in those countries to get like more fine details about the pandemics. And also the second part is like the adaptability of public health policy and social acceptability of AI technology in respect of ethics and human rights. So as I said, a lot of COVID restrictions and even AI technology come from abroad, and we don't exactly know if they are adapted to the social context in Mali and Senegal. So the first thing is to look after that. And there is like many other topics like gender, laws, ethics. All those things are really important, so we try to study them as well. So the survey, so it was my main, for me that's working on NLP, it was my main sources of data. So there is a nationwide survey in Senegal, so all over the country. In Mali, only 2 regions, because the other are, it's in red zones, so it's really dangerous to go there. And so Mali had a sample of 100 people, 1,000 people in Senegal, and 550 in Mali. And the topics of the survey was genders, ethics, law, and the socioeconomic of people living there in each region. And also the survey section, you have like more specifics, themes on knowledge of perception and experience on COVID-19, and the perception of AI solution, and also vaccination. So why did I use NLP? So prior to join this project, I have like previous experiences in NLP. So I work with, I work in the industry, when my project was to gather the customer reviews, and then from there to know which customers are not happy at all, and to know why. And then from there, we can like provide some changement to the business side so they can improve their services. So I did that, and I really worked extensively on these projects. So in my project, there were a lot of open-ended questions. So I think the survey was more than 100 questions, and I think about 20%, 15 to 20% was open-ended question. So it would be like really a tedious work to go one by one and try to read every question and get the sense of that. So my idea was use NLP so we can get a lot of time, and also it can allow us to really read between the lines. And also the other part was the lack of data in the subject of interest, because I didn't heard a lot about like a survey on the perception of AI, and even all the ethics that go around like data protection. Because even if there is law, we don't really know if they are applied there, or we don't really know the context. So it was really interesting to get that. And even the sentiment of feeling of people. So we are doing like 2 surveys every year in Senegal, so we can really see like the evolution. So when the pandemic starts, how people like interact with those changes, with those restrictions, and even the new artificial intelligence technology. So I think it could be a nice thing to work with NLP. So what the type of NLP I used was really not fancy NLP, just topic analysis and gram analysis and sentiment analysis. What was the survey challenges? So both in Mali and Senegal, you have, it was hard to do that. It's not like in Europe when you want to do a survey, you can call Ipsos and they can do the survey for you. There it's way harder. Basically, you have a team of students most of the time. You just have to run them a motorbicycle, a tablet, so they can like register enter the survey, and also like a mobile phone, so they can call you in case of issue. And they just basically take the motorcycle and travel all around the country, and just talk to people and get their feelings about the COVID and artificial intelligence. So the first problem was the low literacy rate. So it's really an issue in those countries in West Africa. The literacy rate is really low. So sometimes when you are it can be hard to explain the really difficult terms. So in local language, it's hard to translate artificial intelligence. So that's what a big challenge is. And also it's nationwide, so sometimes it can take times. Okay, so first thing we did for this survey was the pulsar training. So we use a field data collection software. So we do Scopo Collect. I think it's software from UN OCHA. It allows us to just design the survey and just get data every day. It was really, really useful. And then presentation of the course on AI and ethics. So even it's hard terms for a lot of people, so you want to make sure that the pollster know exactly what are AI and ethics and how they should like question during the survey. And also the translation in many local languages, so as I said earlier, sometimes are complicated to translate, so we struggle a bit with that. And also there is like a test at the end to see that the pollster really understand everything, so we can improve the courses. Okay, so even when you have like good pollsters, we need to check every day that the data we're getting is quality data. So that's so every people that work in data science and artificial intelligence know you can be better than the data you have. So if you have good data as a source, you can do a good job, but with bad data, it's really hard to work. So I did like monitoring systems, so daily data collection, so we can see, we can check that every day. And I also did some custom dashboard. So for example, the survey was long. It was like more than 100 questions. So I had to check. So sometimes some pollsters want to do more survey in a day, and it's not possible. So we'll try to track that. And also track open data questions. But sometimes because the survey is long, some pollsters they just want to finish the survey as quick as possible. So sometimes we have to check that there are enough text. Because for me particularly, if you want to work with NLP, you need a lot of textual data. And also, you have day-to-day reviews with pollsters. So every day, you try to check what they have done, and just send them like guidance so they can improve the work day by day. And also the analysis challenges. So a huge issue I have is I have to correct after because the survey was so long, sometimes the pollster just pass really quickly on the questions, and they have a lot of grammatical errors. So I have to spelling mistakes. So I have to correct a lot of them manually. Sorry. And also I use like process like stemmings, the stop words. That's really classical like pipeline in NLP analysis. And also the problem I had is I tried to get as much text as I could, but the text was not really enough. So even for the topic analysis, I just had like three distinct topics, not more than that. And a lack of variety of words used. I think it comes from two things. The first one is like the translation. So when you translate, you lose some information. So, and also, as I said, a low literacy rate. So people don't use like really diverse, diverse words. Okay, so the first example. So we actually writing an article on that. So the vaccine hesitancy in both Mali and Senegal. So we have like quantitative data, so we can know like how much people want to get vaccinated. And as we saw, the people were really against the vaccination at first. So more than half in both Mali and Senegal were against vaccination. And at the time of the second round of interview, it was already available, but people refused to get vaccinated. And the topic analysis, so in this case I used LDA, really help us to know why exactly people didn't want to get vaccinated. So the first fact was the fear of vaccine. So a lot of them said that, oh, I don't know what is inside. And also they were saying a lot of people in developed countries, in Western Europe, in the United States, Canada, they want to get vaccinated. So it seems like a really bad thing, so we shouldn't do that as well. And also the disbelief in vaccine efficiency. So I think for the main reason, the general distrust in public health systems. So in those countries, there is a really distrust in the politics. So they said that, oh, we don't know what's inside. And there was also a lot of conspiracy theories. I actually heard a lot while I was reading the comments. People would say that, oh, maybe they want to, I don't know, there's something like they aren't sending the best vaccine, so maybe there's something inside against like people in West Africa. So I also heard a lot of that. So this is an example of the synthesis of the synthesis of the LDA. So what I've done is just we have a bag of words by topics, and then by reading the comments, I tried to get a representative response of what people were meaning. Okay, so and now I have the improvement for the next survey. So on the survey side, our main problem was the number of questions. But the survey was really long, more than 100 questions. We don't have like enough time to dive into the subjects. So this can cause a lot of issues, so small response. So we decided for the next round, because we still have two rounds of interviews, so increase the time spent on specific topics and add a lot of more open-ended questions. So now we know that we have like a ready pipeline to study them, so it can be really interesting. And just die. So for example, in vaccination hesitancy, you can just ask more questions. So you don't get vaccinated, so why do you distrust the states? And you can have like a better understanding of what's happening there. And also puts the emphasis on explanation of complicated terms. So you can like contact people who are specialists in translation of local languages, so they can really try to make their term like artificial intelligence, explain them in local languages, so we can better explain it to the pollster, and then we can get like better quality information. And also, when it's possible, we can get like collect voice message in French, and then use it as an input for the analysis. That was all from me. Thank you.
Thank you very much, Abdine. That was fantastic. Do we have any question for Abdine? We can take one or two questions. Yeah.
Yeah, thanks, Abdine. Do you have a technical? Sorry, thanks. Do you have a technical solution to translate voice into text?
I was looking for that, but most of our algorithm there is a lot of like errors. But I think it's better if we have that, because most of the time when someone went to with a pollster and they really like cut a lot of text. So maybe if you get like the text, we have like the written response and the voice text, the voice. The voice recording. It can be better to understand what's happening. I mean, I want to have like both.
Okay, thank you.
And things like Google can translate the voice. It's not perfect, but you can get some text.
Great. We can take one other question. Any technical, non-technical, personal, non-personal question for Abdine? Yeah.
The results you got from these surveys, were those in line with what you assumed the perceptions would be, or was there anything that surprised you about it?
No, actually it was really surprising. Because the thing is, I used to live, I lived in Mali and Senegal when I was younger, but I left like 10 years ago. So when I did these interviews, a lot of things, I didn't expect a lot of things. So the conspiracy theories and everything, so I didn't expect that. So a lot of like results was really surprising.
Okay, did we have also a last question?
No, it's more a comment than a question. So I've been working in vaccine hesitancy for many years, and it's surprising that, I mean, we don't have any data for Africa, but it's surprising that you are perfectly in line with whatever we see in literature from other countries, because we work with social media and digital data. Okay. And it's really surprising. I mean, for me, it was really surprising to see that the concerns of the people are the same.
All right, once again, good morning, everyone. My name is Ted Londner. As was just mentioned, I'm a member of the technical staff here at MIT Lincoln Laboratory. And I'm going to be presenting some work that we've done to develop a prototype software system that automatically scans and extracts key indicators from humanitarian documents. And like I said, this work was done on behalf of the United States Agency for International Development. So I'll start a little bit by talking about where I work. That's MIT Lincoln Laboratory. The lab is a federally funded research and development center in Lexington, Massachusetts, as was mentioned, about 70 years old. The core mission of the laboratory, which is a part of the Massachusetts Institute for Technology, is technology in service of national security. But underneath that heading mission, there are actually a lot of different mission areas that we work in. Mission area that I work in is biotechnology and human systems, and within that overarching mission area, I'm a part of the Humanitarian Assistance and Disaster Relief Systems group, which aside from those two core elements of the mission. We also work in global health and in climate change. Now, within that body of work, we have a few projects that are sponsored by USAID, including the work I'll be talking about today. The motivation for this work is that humanitarian analysts essentially have a whole lot of information that's out there that they could make use of to help drive decision-making for their institutions. There are a lot of documents that are written and available to them, but there are so many of them, and the efforts that are out there to curate them are so infrequent or incomplete that the number of documents can overwhelm these analysts, making it difficult for them to have full situational awareness and fully inform their decision making. And so wouldn't it be nice if there was some sort of software system that could make the job of extracting data from these documents easier for them? So motivated by this, USAID approached us and asked us to develop a prototype software system that could do this sort of thing for them. So we developed something that we call the indicator extraction tool. I'll talk a fair amount about this over the next few slides. What it does is, based on documents, PDF format documents on ReliefWeb, it scans them and extracts numeric indicators. So these are sentences saying things like number of people that were displaced, number of people in need, number of refugees, and so on and so forth. And then it either extracts those indicators and puts them in a spreadsheet, or it highlights them in the source document itself. This work proceeded in 2 phases, each 8 weeks long, and these phases took place, there's no year noted here, but both of these sets of dates were last year in 2021. This is the high-level schematic of how the tool works. Based on search criteria that the user specifies, the tool scans ReliefWeb for documents of interest. It then processes those documents to extract the key numeric indicators, or then it either puts those indicators in a spreadsheet or highlights them in the source document. And after that point, the indicators can be visualized in any way that the analyst might want using other kinds of software. A little bit on ReliefWeb, for those of you who may be unfamiliar with it. ReliefWeb is a very large repository of documents of humanitarian interest that's maintained by UN OCHA. Almost 1 million documents as the time that I put this presentation together. But the key thing to note as far as this presentation is concerned is that the website has a very good API that can be used for customized searching and to identify files that you want to download. So the web scraping component of the indicator extraction tool, we just programmed in to make use of ReliefWeb's API, which made it fairly simple to find documents that we wanted to download and use our tool on. A little bit about humanitarian documents themselves. As I've mentioned, these documents tend to contain useful information for analysts to work with to help drive decision making for their respective institutions. There are lots of different kinds of humanitarian documents under format names such as situation reports or appeals. As I mentioned, a lot of the information is contained in these key numeric indicators, which have many different types to them. And there's so many documents that it can overwhelm analysts if they don't have either a large team or some kind of software assisting them in their jobs, which of course motivated the tool that I'll be talking about over the next few slides. Now, within the individual documents themselves, information is also presented in a variety of ways. You have sort of main body paragraph level text, like over here on the top left. But information is also presented in these infographics and tables. All 3 of these formats are designed to be easy for humans to read, which is of course the intent of these documents. But they present a variety of different kinds of challenges for computers to read. And I'll talk a little bit about that over the next few slides too. But it is worth noting that, at least as far as the documents we've seen, the ones that are written in English, the humanitarian language we're terming it is fairly similar. So the way that you would talk about, for example, displaced people in one document is fairly similar to what you would find in another document, which means that you can program a computer to identify those kinds of indicators within the documents without too much trouble. This is, over the next few slides, I'm going to talk about the process that the indicator extraction tool goes through to identify and extract those indicators. So again, the first step is to locate and download PDF documents, in our case from ReliefWeb. And our search criteria were based on which country you were interested in, the dates of publication of the documents, and the document type of interest, things like situation reports and appeals. Then the PDF version of the text was converted to raw text, which was necessary for the kind of processing we were doing, which was using regular expressions. Now, when you're converting paragraph level text to raw text, typically you don't run into any issues in our experience. But when you're trying to convert infographics and tables, then you can run into problems. So for example, this is a sampling of one of our original documents that we worked with. You can see, for example, that the subject of each number is written right next to the number, making it easy for a human to understand. People in need is written right next to 23.5 million. But when you convert this to raw text, because of the way the PDF was formatted, then the subject of the number and the number itself becomes separated, which makes it very difficult to know with any sort of regularity that, for example, 23.5 million is associated with the statement people in need. Now, in the way that we extract text from the document, we also keep a record of the geometry of the document. So for example, we know where this number is and where that subject is within the document itself. And so theoretically, you could realign those things using some sort of smart way to try to reassociate the numbers with the subject, but we haven't done that work yet. So for now, we're subject to the problems associated with extracting the text from the documents and converting them to a raw form. The next step is to take the text and to split it into sentences. Our tool works at the sentence level. And then based on a large body of regular expressions, identify where the numeric indicators are and what the numbers associated with them are. So for example, if we split this paragraph here on the left into raw text, we get these, into sentences, we get these 3 sentences here. And using this particular regular expression, we can identify the indicator 8,000 people are displaced. Now, for those of you who may not be familiar with regular expressions, they are strings of characters, like the ones you see here, that represent patterns of text you can identify within some larger body of text. So this string of characters, for example, represents a variety of things. We're looking for sequences of numbers and spaces and so on, and also the particular word people and displaced. And this was one of very many regular expressions that got programmed into our tool. So we extract 8,000 people are displaced here. Here it's fairly easy to recognize the number because there's only one of them. It gets a little bit more ambiguous if an individual sentence has more than one number in it. Now, you might ask, okay, so how do you program in the regular expressions to identify all these different indicators? So the indicator extraction tool uses about 13,000 regular expressions, but we certainly didn't program in 13,000 individually. The same way that grammatically a sentence might have a subject, a verb, and perhaps an object. These indicators typically have a number associated with them. They always have a number, actually. They have some sort of object, like how many people or persons or IDPs and so on. There may be some kind of action, and there may be some kind of assistance associated with each one of these indicators. So instead of programming in 13,000 indicators, we simply populate each one of these bins, if you like, with a list of things corresponding to each subject area, and then we just find all the combinations among those 4 bins, and the combinations, which we create automatically, help us reach this number of 13,000. So it's fairly easy to add new indicators by adding new quantities, new entries to each of these bins, which will then automatically generate a large set of regular expressions which you can use to find more indicators. And here's just a sampling of a bunch of different kinds of sentences that you can find using just a small sampling of the regular expressions we had in our tool. The last step in the indicator extraction process, once you've identified the indicator, you either output it to a spreadsheet. This is a sampling of one of the rows of that spreadsheet. You can see there's a lot of different entries here. Or you can highlight it within the original document itself, which some analysts we've spoken to seem to prefer. And here's just a sampling of that for the same indicator. Now, in our experience, this method works fairly well in a limited way, and there are 2 important challenges that we face that are worth noting here. First one is, it's currently not possible in any kind of meaningful way to systematically judge the performance of the indicator extraction tool. I mean, we can get a sense for how well it's doing based on looking at a small sampling of documents and showing analysts its performance in that regard. But in terms of its precision and its recall over large bodies of documents, at the moment we can't do that. And the reason why is because we don't have a large corpus of pre-labeled truth documents available to us that have been labeled according to the definitions of indicators that our sponsors asked us to work with. We would like to have one, and it's one thing we've been thinking about over the last few months as we contemplate future work in this area. And of course, one other advantage of having a large corpus is it would allow us to transition from regular expressions to more advanced machine learning techniques that would no doubt have better overall performance than regular expressions. The other thing that we would like to be able to do, but is currently difficult, is disaggregate the indicators based on geography and based on cluster. I'm going to explain over the next couple of slides, or the next slide, I think, why this is difficult to do. It's the same example that I showed a few slides ago. This is that paragraph of text I showed a little while ago. Split that into sentences, and then we match this middle sentence against a particular indicator of displaced people, and then we extract that indicator. 8,000 people are displaced. Question is, where are these people displaced from? Where are they going? When were they displaced? And what are those people's needs? These correspond to the geography and the temporality and the humanitarian cluster associated with this indicator. And it'd be nice if we knew this information too, and didn't just present, 8,000 people are displaced, which by itself doesn't necessarily mean very much. The issue is that this other information is not in the sentence where the indicator is. So the location and the time information, for example, is in the previous sentence. Humanitarian cluster information is in the subsequent sentence. And there are going to be plenty of examples, of course, where these things are in much farther off sentences than just the previous one or the subsequent one to the indicator that we care about. So identifying the indicator and just using these regular expressions to find these things, it turns out that's fairly easy. Doing this other business where you're trying to disaggregate the indicator based on location, time, and cluster, that is difficult. And so, especially without a corpus to work with that we could use to train more advanced techniques, this is currently beyond the reach of our tool. And it's either at or beyond the reach, as far as our understanding goes, of the cutting edge of natural language processing tools of documents. So it helps in our minds to think about what a tool like this might do as taking place on a spectrum, where on one end you have a fully manual system where essentially there is no tool at all, and humanitarian analysts are just doing what they do now and looking at PDFs on computer screens and trying to read them as much as they can. And on the other hand, you have a fully automatic system where the computer pretty much does all the work to identify and extract information and present it directly to the analyst. The initial version of the indicator extraction tool, the way that it was asked to be designed with the disaggregation intact, is a bit beyond our understanding of the state of the art at the moment. But there's a lot of space in this blended design region where you're trying to take advantage of what humans do best, match it with what computers do best, and create tools that can still save a lot of time and energy, but are much more feasible, especially with low or with no or a small corpus of humanitarian documents to work with that have been labeled. So as we look at next steps or anything that we develop, we'll be exploring this blended design region to see where that might bear fruit for us. All right, and in conclusion, I'll just remind everyone that we developed this tool we call the indicator extraction tool that looks for and tries to extract key indicators from humanitarian documents to help make their jobs easier. We did demonstrate its basic functionality to identify and display those indicators. Follow-on development would be very much helped by a corpus of truth-labeled documents. And as we go forward, we're going to be looking more into the blended design aspects that might still help analysts do their jobs without being a fully automated system. I'll stop there for questions. Thank you.
Great. Thank you very much, Ed. That was a fantastic presentation. I really like especially the slide before the last one. Is there any question for Ted? Any question? Yeah.
Hi, Ted. I am Patrice. Thank you for the presentation and thank you for the tool itself. I have is it available online? Is it available to explore? Can we play with the tool? Is it proprietary? Is it open source? How have you designed the tool itself?
It's a little difficult to hear. Was the question, is there a way for others to play with the tool?
Yes. So my first question is it possible to explore the tool and its functionalities? Second, is the code available for looking at how it is being built, etc.? And third, I guess, what is your plan for the future? You mentioned that you would like to work on the corpus, etc. Do you already have a plan which is rolling regarding the next steps, or are you waiting for more funding, etc.?
Okay. Forgive me if I didn't understand everything, but I think I got the gist. Microphone sounds like it's not transmitting very well into the Zoom. The tool, unfortunately, is not available publicly at the moment. It could be that it's done sometime in the future, but for now, we're keeping it under the control of our project sponsors. We'd like for others to be able to play with it one day, but unfortunately, that's not the case right now. And beyond that, our future plans for the tool, we're developing those right now. The field is pretty wide open in terms of what we might want this thing to do. And so we're formulating our plans with the sponsor. And I'm hoping that we get many more months to work on it and develop it further.
Thank you, Ted.
You're very welcome.
We have time for another question. I actually have one. I think it's easier for you to hear that here, right?
It's a little bit easier.
Okay. So the question is about, you talk about basically the lack of data here, and it's hard that you have enough data for training a machine learning model. I'm just trying to ask two questions and put them in one question. One is that how much, there are other domains that exist for them enough corpus and training data for extraction. How much is possible that you transform something? How much this domain is different from the other general English domain? How much is possible that we use the data that exists in general English and try to transfer that to this domain? And a little also related to this question, I think that you are mostly working on an English language. Is there also other languages that are involved here? And yeah.
Yeah, interesting question. Thank you. So in response to the first, I think that there will be opportunities to make use of existing label documents, especially that have been done in the humanitarian domain already. What's not clear to me is how sensitive the performance of the tool will be if we train it using these other documents, because the specific indicators that we were asked to look for, they may not be reflected in the existing corpora. So obviously it depends on how close those corpora are to the specific indicators and other things that the tool is being designed for. But there are plenty of unexplored opportunities in that area, I think, if we carry this work forward in that area, in that regard. And regarding other languages, it's not something we've looked into yet. Obviously, it'll come with its own, its own challenges in terms of figuring out how specific indicators are represented in those languages. But for the same sponsor, we have been looking into the utility of machine-based translation of humanitarian documents. And as part of that work, we thought briefly about how that might be incorporated into the development of this tool. And I imagine that as the tool development proceeds down the line, that the machine translation may become an aspect of it. Hopefully that answers your question.
Yes, so thank you very much. Thank you very much all for wake up so early, and wish you a very great day. So just so for the
Thank you very much.
Good morning, everyone, and thank you for being here at this talk of the deep dive into natural language processing for humanitarian crisis response track. I'm Nicolò Tamagnone. Thanks to the collaboration between ISI Foundation and Data Friendly Space, I joined the Data Friendly Space team the last year, developing AI and NLP solution for the DIT platform. The title of my presentation is Advancements and Challenges of Applying NLP to Humanitarian Data Analysis. First of all, this talk is focused on 3 main points. First of all, a brief introduction on what it is and what and why it's difficult to do data analysis in the humanitarian sector. So on this, for those who were present, you can refer also to the previous talks by Patrice, Iwan, and Leonardo. Then we will talk about our approach to improve or at least reduce these problems, and how AI and, in our case, NLP, can be powerful tools to improve them, and how we apply all these within the DEEP platform. And then a quick list, finally, a quick list on our next steps and improvements for the solution we propose. So we start with the first point, that with a question: what is so hard in humanitarian data analysis? As the titles I initially listed say, we are dealing with the correlation between humanitarian response and data analysis. An effective response to humanitarian crisis relies on as much as possible detailed information about the needs of affected population by any kind of humanitarian crisis. And then nowadays there is a overwhelming amount of data, especially in the humanitarian sector, especially of qualitative data. And so there are many advantages making proper use of this huge amount of data, because analysts have access to a lot of information, news information, and in real time sometimes, and it can make better informed decisions. But there are some problems. The first problem is that it's due to the big quantity of data, so organization and analysts cannot handle independently this huge amount of data. And then probably the most important thing that it's concerned the complexity of the data. We are talking, the decision makers face the challenge to identifying crises between a lot of different information, and so identifying and separate what the information that you need from those who don't need, it's not easy. And so a lot of data remain unprocessed. Oh, probably. Okay. So the starting point, as we said, it can be, first of all, a lot of data, and then we are talking about mostly of qualitative data. It's of a structured type here, so like PDF, website, reports, Word documents, etc. There are some software solutions available to manage and process qualitative data in the humanitarian sector, and one of them is DEEP, that it's a platform developed by 4 humanitarian actors to process huge amount of unstructured data. Using this science, it helps humanitarian organizations to collect and categorize data from different sources, selecting interesting information, except of text like sentence, images, maps, tables, etc., using some categories of interest, and then use and export this data in a structured form for further analysis and doing maybe secondary data analysis after that. And so I highlighted the tagging step in red here because it's where it's the crucial point of our development lies. The annotation and categorization of data takes place according to some, as we said, according to some categories of interest. That is, each project, referring maybe to a particular humanitarian crisis, will need to search for specific information within the data. And we call this set of categories like analytical framework. These analytical frameworks are very often very complex, composed of a lot of different tags, different labels, but it's not a, usually it's not a scattered list of labels, but are labels that have relationship between them. And then in addition, text, it's text that we want to categorize and the information that we want to find are also can be very long, so adding also further complexity. We show here an example of some labels. In general, we can find three main properties. The fact that they can be used in a multi-label way. So, for example, a certain information can belong to several tags at the same time. So, for example, a sentence can be COVID-19 and talk about cases and contact tracing in the same time. As we can see here, we can have a hierarchical relationship between the labels. For example, here we have two layers of hierarchy and relationship within our labels. And then the last aspect, although not strictly related to the labels per se, but it's that we can apply the data is qualitative form, so mainly in text form, and the text can be in different languages, so it's a multilingual system. Here in the DEEP platform, we divided the analytical frameworks in two main categories, the primary tags and the secondary tags. Here we can see a part of an example of the relationship, a three hierarchy level relationship between some groups of primary tags, sectors, and then 2D pillars, 2D sub-pillars that are only names that we use to create groups between the different levels of the hierarchy of the labels. But however, it's not a goal of this presentation to show the details of all the labels of an analytical framework, but I wanted to show the complexity of the task, and so the need to make a step further, for help and improve humanitarian data analysis, and in particular on this activity of categorizing and tagging the data. And so let's move on the main part when we show what we have taught and developed to improve and speed up the tagging activity, compensating the complexity of the data and these tags and this task. So within DEEP, or maybe in general in the humanitarian analysis, in each project, each humanitarian analyst can upload a data source of many different types, as we said, like a PDF, a report in PDF, a Word document, so docx, doc, a presentation like this one, also a web page, news from every site, so therefore the main data is mostly in textual format, but not raw text, it's a digital document. And so how can we use AI and especially NLP to solve this problem about large amount of data in digital documents or website and categorize the data, the text inside the documents? Our approach was to work on two things in parallel. The first is a pre-processing part, and in parallel develop an assisted tagging tool, so classifiers, helping analysts to the annotation of this document. Let's start with the pre-processing part very quickly. As we said, we are talking about qualitative data, especially in text format, and especially digital documents. So the problem is that raw text extracted, there are a lot of tools, commercial, also open source, that we can use for extract text from documents, but very often the text extracted from using these tools from these documents is super noisy, especially for this kind of humanitarian reports, humanitarian documents, where there can be very complex, with a lot of complex layouts, graphical components, tables, images, maps, etc. And also from web pages, the news article, because inside website we can contains a lot of useless text. Maybe the only thing that you can extract and you are sure to extract is the title. But then inside the raw text inside the web page, in addition, there is a lot of useless text, like ad, advertisement, menus, etc. So we develop an open source library, a PDF text extraction tool. You can scan. You can scan the library from this QR code. Here are some example. It's not the main goal of this presentation to show the details, but it's a recursive algorithm that recognize also and take in account the graphical separation of the text and the relation, and also here another example, and also the detection of the table and the graphical images, and then refine the detection, and so we can also structure this data in a second part and separate the text inside the tables from the main one. Here a little comparison between a very famous tool, AWS Textract, that it's a different tool using 100 documents in English, and here we can see that our tool, for our purpose and our kind of data, is much faster and also more readable. And so, as we said, in parallel to the pre-processing, we have developed an assisted tagging tool. All the documents uploaded to the platform are manually annotated by the expert in the humanitarian sector so far. And so what we want to do was to improve and speed up the analysis of the text, providing live recommendation to the taggers. In this case, the process, I want to plot the process in a cyclic way because after the development of classifier, so giving live recommendation to the taggers and deploying this classifier inside the deep platform, the users can confirm or reject our suggested tags, and so this gives us the possibility to monitoring our prediction, the feedback of our model, and use the new data, also the corrected labels that the user rejected, for new data, so creating a sort of kind of continual or continuous learning scenario. Our model have to fulfill some criteria for sure. The first things, the good performance. The second one, that it's the critical part, because we want to suggest live prediction to the taggers when they are working on tagging in real time, so fast prediction, work in different languages, and also handle imbalanced data. Is probably the most complex things, because many tags which are not represented the same way, it doesn't mean that are less important, but here we can show it's a super unbalanced, not only information, and I have different occurrence, okay, also in the news and also in the reports. And so, as mentioned, our assisted tagging tool is based on classifiers, okay, capable of suggesting labels given a text, and we use a set of labels that here we call a NLP framework that it's created combining different analytical frameworks, so different set of labels from the most important project inside the DEEP platform. And then we trained 3 different classifiers with 3 different architectures, depending on the hierarchical structure of the labels, as we saw before. And we obtained these models starting from a distilled task agnostic transformers model that give us the possibility to apply that to arbitrary tags, in our case a classifier, but maybe we will do something else also, and also different languages. So it's a multilingual model. Here an example, so given a text, a sentence, there's not only one sentence, but can be also 2, 3 sentences together. This is an example of inference using our classifier. For sure, follow up if you want to see a more detailed model description and then results. We have our workshop at 2 p.m. Here, however, some results, some average metrics between all the primary tags. It doesn't seem so bad, but we can see also during the workshop that a more in-depth analysis can show that for sure labels that are less represented and don't work so well. And also there are some labels there is a complexity related with the framework because between the labels, because some labels have a weekly difference between them. Okay, we can understand the difference between people in need and people affected, but for a machine learning model, it's pretty much the same things probably, so it's not super easy to do. As mentioned, okay, here are some challenges about the data, so find new data, especially for underrepresented tags, and in this case, as we saw before, a continuous learning scenario help us, or maybe we can try to collect new data, specific data collection for the labels that are underrepresented, and then add to the model for some specific task, maybe some heuristic of knowledge-based information to improve in parallel to the machine learning models. And so, some next steps, very quickly. First of all, we already started to work on this humanitarian BERT, that I call Humbert, the textual data. Yeah, our starting point, and as I said before, is a pre-trained language model, task agnostic distilled one, that is trained, but as a lot of this kind of pre-trained model are trained starting from super generic text, like common crawl, wiki, etc. But in the humanitarian sector, language can be very specific, can be different from the wiki text or a news text, etc. So we start collecting a lot of non-annotated humanitarian textual data from different sources, and so creating this humanitarian corpus, and use this humanitarian corpus to train from scratch a custom language model that we will use as a backbone, a custom backbone for our downstream task, okay? So it's a kind of masked language model, so a BERT-like model that we will use for subsequent tasks. And then, last but not least, a task on we already started working on information summarization and also, and in parallel also natural language, after that, natural language generation. I separate the slide in 2, so some classic summarization task, so in an extractive way, so like, I don't know, like a text rank model, so to improve, and because now our classifier suggests labels of a text expert that is identified by a user. But we want to recognize maybe, we want to speed up much more this activity and recognize some expert of text before in an automatic way. So a summarization of the whole document text based on our labels, and then after that, natural language generation. So it's a very similar task, but in an abstractive way. So starting from maybe also structured data, create a text, a report of starting from this data, so more readability. Thanks, and that's all.